Good afternoon. If you're watching this video, you probably attended my workshop on behalf of HHMI Biointeractive at NABT 2020, where we discussed a resource called Lizards in the Cold with the theme based on the idea is extreme climate change driving evolutionary changes in populations such as Anole lizards. This is an additional activity that looks at the same question. This is called Lizards in Hurricanes. And the frequencies of hurricanes as they increase in the Gulf region, are they having selection pressures on the Anole lizards? Are they actually causing a change in the population's traits? So I'm going to do a brief walkthrough on this Lizards in the Hurricane since there was not enough time in our session to go through both resources. So let me share my screen. And we're going to open up, this is a presentation that's done in a program called Mentimeter. Same one that I used for the presentation on Lizards in the Cold. And so Lizards in the Cold was a data point activity. This is a phenomenal image activity, using images to drive questions and explorations of key ideas in biology. So we're going to start with this image here. In your resource folder, there's a link to the image if you would like to take a look at a larger picture of it. In a moment, you'll also have access to a larger image as well. And so what we start is we give the students this image without any further background. I wouldn't have even mentioned hurricanes if I was doing this with students yet. And we're going to ask students to look at the images and come up with some observations and some questions that the images might stimulate. I give them a little bit of a closer look at two of the cells. This is lizard A and lizard B. And then I like to share with them about 15 seconds, 20 seconds of a very short video. So let me play without the sound on, So let me play this for you. And so then I move on from, that video. You may want to stop it before the title where it says Lizards in Natural Selection. I'll leave that up to you. And then I like to get students into groups to take a look at the images and, like I said, generate some ideas and some questions. At a conference like this, I might use something like Jamboard to allow groups to work together and discuss the ideas. So what I would do in this particular case is I would have breakout rooms. I would randomly assign you to breakout rooms, and I would also give you a link in the chat to the Jamboard. There are limits on how many people can use a Jamboard at once. If this was with my students in my classroom, it's no big deal. We use Google Classroom. I would just simply assign each student a copy in Google Classroom, and it would be easily distributed. In a setting where you don't have Google Classroom, I'm going to just exit out of this slide program for a moment. Go to my folder here. Here's some Jamboards, if you've never seen this trick. So here's Lizards in the Hurricane. What I do right up here where the address is I take out the word viewer and I replace it with the word copy. And then if you share that with any participant, what that's going to do, I'll paste it in, is it automatically brings up something that it causes the participant to have to make their own copy of the document so that they can use it. So a lot of the Google Docs have limits of about 50 people on a single document. And so if you're doing a conference or any type of workshop with more than 50 people, this could be a way to share it, or a way to share it with students if you're not using Google Classroom. They could then make a PDF copy when they're done and send that PDF copy to you as the instructor as evidence of their work. Just a little tip based on my experiences from trying to prepare this presentation. So let me jump back into where we were. So we would send you out to breakout rooms and to use the Jamboard. So let me go to the Jamboard. This is not going to be super smooth. I apologize. Trying to run this, if we were running this as a live session, we can make it much smoother. So I gave you the link, you pulled up the Jamboard, and this is what the Jamboard would look like. So this is the first slide in the Jamboard up here. If you've never used Jamboard, very, very quickly. These are different whiteboards. You just use the arrows to scroll through the whiteboard. So you can see I have 3 whiteboards already pre-set up. These are the tools, the pens, the erasers, the cursor, images, shapes, text boxes, all of those types of things. So I'm going to have them primarily use sticky notes, and I'm giving them some prompts to maybe help them, such as I noticed, it reminds me of, I wonder. I also explain that if they can't see the image very well, they can use this magnifying glass up here, and they can zoom in and get a little bit tighter and blow the image up as much as they need to. And so then we send them off to their Jamboard. And here we have the blank Jamboard. Again, they can magnify it if they want. And we start looking for observations. And so I'm going to make a sticky note. I can pick a color, say I want to put a green color, and maybe I noticed near the end of each picture sequence, the lizard is not able to hold on to the pole. And so that puts this Post-it note here. I can resize the Post-it note. I can make it bigger, smaller, et cetera, et cetera. If you want students to collaborate, again, if you share it through Google Classroom, they can all be working on the same Jamboard, or you can have one member in the breakout room share the link with everybody, share the Jamboard with everybody else, and they can all work on the same Jamboard. So I would have them work through, come up with some statements. Again, there could be questions as well. And then after they've spent a few minutes on that, we would ask them to, so based on your observations, what's at least one research question the scientists might have been testing through this experiment? What were the scientists trying to do? What the heck do we got lizards on a pole for, and they're going vertical? What's happening? And so again, we would use Post-it notes, and using Post-it notes, we hope they would come up with some type of questions. You know, I'm just going to randomly make up, you know, what is making lizards unable to hold on to the pole? Again, I'm trying to think like maybe a freshman might think. And I can save that on my board. And again, we'd have others save theirs on theirs. So we'd have this 5-6 minute discussion based on these images. We'd then return to the main room out of our breakout room. So let me return to the main room. And when we return on the main room in a workshop like this, you saw in the lizards in the cold, I would have some poll questions. This was done with Mentimeter. There's lots of polling apps out there, lots of polling tools out there that you can use. Zoom itself has a polling tool built right in. So please share 1 to 2 observations or questions that came up in your breakout room. And we would ask people to just sort of type in, everybody's contributing. And Unfortunately, I don't have another person on the other end to make this work right now. Hopefully you saw the lizards in the cold so you get an idea how this would look. But there'd be bubbles sliding up with different people's responses. And we can pause every so often and stop and look and sort of get an idea what people are thinking. So it's a way for everybody to contribute their ideas back to the main group. Next slide would have said, what is a possible research question? We'd have them shout this research question. In this case, instead of sliding boxes, this was just bubbles. And bubbles start popping up on the screen with all the different ideas of what the research questions would be. And we could take a look at what the group was thinking. So we're trying to get people, just based on the image, to start asking questions, making observations, trying to figure out what the scientific endeavor was in this particular case. After we've done that, we then are going to provide them with information, a little bit of background information, which is found in the student handout, which as I did in the first workshop, there's a handout that has links in sequence for participants to quickly click on. At NABT, you may recall I had a briefcase, it could be in there, and I also would add the link to the chat. So I'm going to pull out of the presentation again, which I wouldn't normally do. And I'm going to just bring up a larger version of that so that you can read it. Oops, sorry. So this is the background information. You might want to pause the video here at a moment and read that. I'm going to give it about 5 seconds, but you might want to actually hit the pause button and just take a moment to read the background information. Welcome back from reading the background information. So now you've got the information to a little bit more context for what's going on. We've purposely withheld that up to this point. And now we move our discussion forward. All right. So based on the reading, their research questions revolved around these. Did the Anole lizard population experience any selection from the hurricanes? Did lizards with certain trait variations have a greater chance of surviving in the hurricanes? And the claim that is made in the background information is that the anoles that survive the hurricanes will have larger toe pads, longer forelimbs, and longer hind limbs than the anoles surveyed before the hurricanes. Of course, if you're making a claim, you have to have evidence to back up that claim. And so we then have a discussion in groups again. Excuse me. So I pull up this map. This is from 2020. And this is just sort of a graphic that shows all of the different hurricanes that have been in the Gulf in 2020. It's been a record year. The last couple of years, we've seen multiple hurricanes in the Gulf. This year we saw I believe it was 3 hurricanes in the Gulf at the same time. So this is an increasing pressure, an increasing environmental change that is going on for these Anole lizards that typically live in the Caribbean. So what else? So based on just the images, do we have any evidence to support the claim? Can you tell whether the lizards with the larger toe pads, longer forelimbs, and longer hind limbs are able to hang on longer as wind speed increases? And so we would ask people again in the Mentimeter poll to respond. So I'd pull down the picture and we would see different people's responses. And a lot of people are going to typically say, I can't see the toe pads, I can't see the bottom of the feet, so I really don't know if there's any way to assess the toe pads. It's hard to tell from the picture the size of the limbs and make comparison between limbs. There's not an easy way to measure the limbs. Those types of comments start to come up, right? And so then we ask another question. So what data might you need to better evaluate the scientist's claims? This one is a word wall and different things will come up, and hopefully we would start seeing that we need to be able to see the toe sizes. We need to be able to have measurements of the toe pads. We need to be able to have actual measurements of the hind limbs. We need to be able to have actual measurements of the forelimbs, both on anoles before the hurricanes and on anoles after the hurricanes. And so we're talking about, good point to have a discussion about what type of data do I actually need in order to back up my claim? What would the scientists have been looking for before they made that claim? What type of evidence would they have needed to be able to make that claim? You almost could, which I've done in other activities. I've not done it with this particular activity, but it's something I could do, is you could almost give them a CER, claims evidence reasoning tool, and you could have them somewhat work backwards on how that might have been pieced together. So typically we don't want to make the claim till we have the evidence, but there's some merit to actually giving them the claim and then asking for what type of evidence would you need to gather to back that claim up, and working through the process in a slightly backwards manner. So if you can get a hold of the original paper in Nature, which you can, there's a link, I have a link in the resources. You can get the paper. If you know someone that has a subscription to it, or you have a subscription to it, or your institution has a subscription to it, you should be able to get this paper with no problem. There are some copyright issues, so I'm not directly sharing any direct information from the paper that we don't have permission to. But within an individual classroom, an individual teacher, with you can buy the actual article for like $6 to $8. You can get some graphs that are in that original paper that provide the data that hopefully your students identified they needed. And from those graphs, they're going to see that forelimbs got proportionately longer, both before and after. They're going to see the toe pads got proportionally bigger. But somewhat surprising to the researchers at the time is the hind limbs got proportionally shorter. Because what they figured out is those hind limbs, if they were too big, they were catching the wind, and that was causing them to blow off and not be able to hold on to the branch. If you recall the video and you recall the images, the first thing to come loose was the back legs. And so they hypothesized that the longer back legs, more surface area, catch more wind, and therefore probably made the lizards more vulnerable in the hurricane. Lizards with shorter back legs may actually have an advantage, along with larger toe pads and larger forelimbs. So the graphs are really nice. It really allows you to have some good discussion. Here's a link to the original paper that you can go to. So then what I do after we've had this discussion, we've looked at what's going on, is I like to play this entire video from Nature. It's only about 2.5 minutes, so let me share it with you.
These lizards are leaping for science. Well, not so much leaping as falling. But their tumbles are helping scientists answer a question. Could hurricanes drive natural selection? Hurricanes are destructive, perhaps too destructive to influence evolution, with species survival being more random than influenced by specific traits. And while some scientists suspect that hurricanes could drive natural selection, this has never been documented. That is, until a group of researchers happened to be measuring Anole lizards in the Caribbean. They surveyed lizards on 2 small islands in Turks and Caicos just days before Hurricanes Irma and Maria struck. Winds reached speeds of more than 200 kilometers per hour, felling trees and flattening vegetation. But after the devastation, the scientists had a rare opportunity to see how the hurricanes affected the lizard populations. They went back and measured the lizards left on the islands. On average, those that survived had larger toe pads and shorter femurs. The males also had smaller bodies. Researchers suspect that these small differences might help the animals cope with high winds. But how? Well, that brings us back to lizards falling into nets. This simple test, done with a leaf blower, demonstrates how they respond to high wind. To stay on the branch, the lizards tuck their forelegs under their body and out of the wind. But their hind legs stick out, catching the wind until they ultimately lose their grip. The scientists say that shorter femurs and smaller bodies could help them hang on. Additionally, the lizard's toe pads are covered in tiny ridges. Larger pads means more ridges and so better grip. Right now, this is mostly speculation, but it could explain the differences the researchers measured after the hurricanes. And that raises the possibility that hurricanes could act as a selection pressure, favoring lizards with wind-resistant traits. And if the traits stay in the population, that could drive evolution. Picking apart processes like this will help conservationists predict how ecosystems adapt to extreme weather events, which we'll see more of as the climate warms. But for now, let's appreciate these little anoles for their contribution to evolutionary science.
Okay. So sort of a nice, neat, short story to wrap it up with. So let me, first of all, disclaimer, no lizards were hurt in this research. The lizards were all caught in a net as they were blown off of the pole, and they all survived and they were all safely returned to their environments. There is a link down below, right here, below the picture, that has the source from where this film came from. And again, I do have links to the YouTube version of it in the resource packet that you can get to. So then we would have time for reflection. This reflection was intended for teachers. You can also do a student reflection, of course, about their learning. And teachers, I would have sent you back to a breakout room for a few minutes. We would have had these questions as a guide for, where in your curriculum sequence might you be able to use this resource? What content connections could you make? What are the strengths of this activity? What about this activity might you modify for your students? So obviously you could put this into something with climate change. It would make great sense there. It could go into something with evolution. That would fit quite well there. And there are certainly other areas in biology where you can make this work, where you can, again, do some cross connections. Speaking of cross connections and other resources, there are other resources available through HHMI Biointeractive that are related to this film, to this resource, Lizards and Hurricanes and Lizards in the Cold. The Lizard Virtual Lab, Look Who's Coming to Dinner, Reproductive Isolation and Lizards. These are all on Anole lizards. There's lots of great resources on the Anole lizards and the research that have been going on with them. And this activity would tie into all 4 of these resources very easily. Or if you want to get out of the lizard world but stay in the evolution world, 2 other recommendations are the beak of the finch, where they look at the changes in the beaks as a selective advantage in changing environments, very similar to the change in the limbs and the toe pads. Selective pressures changing, causing physical changes in the traits of the organism. For a slightly different twist, selection for tuskless elephants is another good comparison piece. This one's different because this seems to be human influenced, much more so than, say, a change in the environment or the climate. So these are other resources we encourage you to explore that you could use in connection with lizards and hurricanes. And also you can see this very much ties together with lizards in the cold if you want to really play on that theme or question, are extreme environments leading to evolutionary changes in Anole lizards? And if we are experiencing these extreme climate changes, what other organisms are being affected and what might be the long-term picture? How much are we going to impact and influence evolution on the planet if we don't get climate change under control? All good discussions, all good questions to share with your students. I'm going to just back up a couple slides. I also want to mention on a lot of slides, you'll see there's this, says mentee.com with a code, just in case you weren't at our other session or have not used Mentee. There is a free version. Students on their phone or any device just simply go to mentee.com. They don't need an account. They don't have to set up an account. They just put in this code and they can respond to all the poll questions that you have worked into your presentation. So all those places where I had questions where I said people could respond, that's how students could respond. So it's a way to keep them engaged and a way to keep it interactive. So I hope this was helpful. I hope you makes you want to consider using lizards in hurricanes along with lizards in the cold. Thank you for taking the extra time to watch this bonus video, I guess we'll call it. And enjoy the rest of your day and keep safe. Hopefully we'll see you at future biology events coming up.